Chapter 11 is the first in a next section of this textbook titled Energy, Climate Change, and Greening the Economy, where we really start to look at the state of the world in terms of these things, energy and climate change, and how we can apply what we have learned previously about economic theory and policy to these situations. And so chapter 11 specifically focuses on energy and the great transition from non-renewable energy to renewable sources. So first, we can look at a couple of pie charts here. This one shows the global energy consumption in 2013 by source. So notice non-renewable sources are huge here: natural gas, oil, and coal, and then the renewable sources, nuclear, hydro, biofuels. Uh, those are much smaller. And then if we look at that same pie chart, but here just for the U.S., so the past one, this one was for the entire world. If we zoom in on just the U.S., the chart looks very similar. So those non-renewable sources make up a vast majority of energy consumption in the U.S. As of 2014. And the book talks about this interesting idea that um, that to create energy requires using energy. And so extraction of oil, for example, requires a certain amount of energy, and natural gas and those things. And setting up a a wind turbine or setting up solar panels, those are things that require some energy in order to then extract or capture energy from those sources. And so this table here shows the net energy ratio. Net energy ratio being how much energy do we get out of this source divided by how much energy did it take us to get that energy out, right? So um, you can see those ratios here, and you can see that the ratio is certainly the highest for oil, um, and then is much lower for, well, highest, sorry, for coal, and then is much lower for other. This picture here shows the world energy consumption by source. So, um, and over time. So we looked at a pie chart. So at one snapshot in time, what did that energy consumption look like? And so here's how it's changed over time from 1965 through 2013. And you can see here that use of all energy sources has increased over that period of time, and that the portion of that that is attributed to oil and natural gas has gotten larger over time as opposed to other uses. So this chapter goes into a good bit of discussion about status quo versus uh, what will happen under certain aggressive policy scenarios where we're really trying to transition from non-renewable sources to renewable sources. And so um, this graph shows the projected global energy demand, or the black line gives the historical energy demand, how it actually has grown over time. And then your red line there shows how it would be expected to continue to grow if we keep policies the way they are now. But then if we try to reduce global energy demand or try to shift demand, uh, increase technology sources so that we don't need as much energy to produce things that we produce, try to shift demand um, toward renewable resources, those sorts of things. Under an aggressive policy scenario, we could see demand for global energy follow the green line instead of the red line. Here's a pie chart snapshot of where we would be, where we're projected to be in 2040, under current policy on the left versus under aggressive policy trying to shift us from non-renewable to renewable sources. So under current policy, notice that pie chart for 2040 looks very much the same as the one we looked at in the beginning of this slideshow, um, of what the pie chart looked like in 2013. So coal, oil, and gas still making up a huge chunk of that chart. If we enact current aggressive policies to try to change that, then by 2040 we could have a pie that looks more like what's on the right hand side, where yeah, we're still using a lot of coal, oil, and gas, but that those percentages have decreased, and we're increasing our use of other types of energy. So this is an interesting picture of what of energy consumption over the past and projected for the future in developed nations. So OECD nations are typically developed ones, and then the non-OECD being uh, developing nations. And so notice back in 1960, most of energy consumption came from the developed nations. That has changed a lot, particularly recently, after 2000 or so. Energy consumption for non-OECD countries has really, really gone up and is projected to continue to go up, while energy consumption in developed nations had leveled off and really is projected to come down some. So then the book, this chapter shifts to talk about some specific types of energy. First, it talks about oil. This is an interesting graph that shows, so the Hubbert curve is a theoretical prediction of what oil production um, would look like over a lifetime of oil reserves. So in the very beginning, when we first discover oil reserves, we just start extracting, 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 and we see that curve go up, the Hubbert curve, the dark black one here. And at some point, we reach a peak of extraction as we start to deplete those oil reserves, and our oil production starts to come back down, according to that theory. We do see over time that U.S. production of oil has pretty well followed that curve until uh, about 2008, 9, 10, and we see that U.S. production curve spike up. The reason for that was developing new technology to find um, oil in new ways. So, most sort of famously, fracking, ways of finding oil in places that we previously couldn't. And so oil production starts to go back up again. It doesn't continue to follow the Hubbert curve. But also notice the darker blue line in this picture is U.S. consumption. So oil consumption up through around 1950 or so, we were producing about as much as we were consuming. We were self-sufficient in terms of oil production. After that, our consumption goes up rapidly and has not really come down, which means we're importing oil as well as producing it. We're using more than we're producing ourselves. And here's just a picture of sort of what that looks like on a global scale in the past and projected global oil production. How much total is expected to be produced in millions of barrels a day, and from what sources. So then we shift to, what about renewable energy? What about renewable sources? And this table gives us the availability of global renewable energy. So a study in 2011 found that for each of the renewable energy sources over on the left column, there's a total global availability equal to the middle column. But then not all of that's available is practical for use, because one of the issues with renewable energy is that though it's abundant, it's not necessarily usable to all geographies at all times. So depending on your climate, depending on how many hours of day of sunlight, those types of things, how much wind you have, you know how some of this is not as usable in some places. And so over on the right hand column we see the availability in likely developable locations. So how much is available, and likely developable. If we wanted to supply all global energy by renewable resources by 2030, here's what we would need to do it, according to that same study. So, that study showed, the middle column here gives, if we wanted 100% of our energy to come from renewable sources, here's what percent should come from each of these energy sources. So 50%, for example, would come from wind turbines. Um, 20% from concentrated solar plants, those types of, each of those uh, sources there is listed. And what would we need in order to accomplish that is in the far right column. So the number of plants or devices that we would need worldwide in order to make that happen are listed in the right hand column. We have seen growth in these areas. So these are over time, starting in 2000 up to 2015. So really, in the last couple of decades, we have seen tremendous growth in solar and wind power. Um, in terms of the gigawatts produced, solar installations are the lighter blue, and wind installations are the darker blue. And so you notice that they really are picking up. They're growing in terms of how much these sources are being installed and used. And as that is growing in terms of how much they're used and installed, we also are seeing prices for those types of energy fall. This goes with typical uh, standard economic theory that as supply increases, prices will fall. So we do see the prices of um, of this is particular as solar energy falling over that same time period that installation and use are increasing. This shows that not only are the prices declining, starting in 1980, prices for solar energy are declined, but also, and this is important, the expected price range for solar energy is getting tighter and tighter, which means we're more able to predict the price of this type of energy, as we move through these years. So as time goes by, that's important because the price of non-renewable sources, oil, for example, is really unpredictable at times. It depends on a lot of things other than just production and extraction. It depends on geopolitical forces and what countries are warring with what other countries, right? And so it's nice not only that the price of solar energy is falling, but that the price is becoming more and more predictable. And we see the same trend for wind energy. The price is falling. Also, that range of prices is getting narrower and narrower. The price is getting more predictable. So when we start to think about the prices of or the cost of use of different energy sources, it's also important, as we've learned previously, to think about not just the cost to me, but the cost to others. So if we consider the externalities of using each of these types of energy, so notice there's a range for each one. That's what the blue bar is it depends on several things, but there's a range of externality costs. And notice that range is much higher for coal, natural gas, for oil, um, for the non-renewable sources. That range of externalities is much lower for the renewable sources. The extra cost to others of consumption is much lower for renewable sources. So when we factor that in, we get this picture. So if we want to think about the cost of electricity generating approaches, not just the cost of the electricity, but let's factor in the total cost, factor in those externality costs. And now all of a sudden we start to see that those conventional sources, those non-renewable sources of energy get much more expensive than if we did not factor in the externalities. And this starts to make renewable sources cheaper um, and more attractive than the non-renewable or conventional sources. So again, we turn to this look of what can happen if we start to make aggressive policy changes to try to shift um, our energy use, decrease energy use altogether, or shift it from non-renewable sources to renewable sources. And we see in this graph is broken down for developed countries, developing countries, and then the total world. And we see that the black bar is where we are. This is energy demand. The black bar is where we are in 2013, and then the dark blue is what we can do by 2040 if we see aggressive policy scenario. If we stay where we are policy wise, what we'll see is the growth to the top of the light blue bar. So we can affect this picture. We can shift our energy pie chart. We can make things um, turn out differently if we're willing to apply those aggressive policies.